In this lesson, we will continue our discussion on the applications of right triangles. More specifically, we will be studying navigation problems. In these problems, we'll be using bearing. Bearing refers to the direction of motion of an object, such as a ship or an airplane, or even the direction of a second object at a distance relative to the ship or airplane. Now, we're going to have two different ways or two different methods for expressing bearing. So let me give you the first method for expressing bearing. The first method will be whenever a single angle is given, it's always understood that bearing is measured in a clockwise direction from due north. Here are some sketches to help us understand some diagrams. This would be 32 degrees due north here. So notice that this is opening clockwise. This is due north right up here, right? And so from due north, opening clockwise, this would be 32 degrees. A bearing of 32 degrees. The next one here is a bearing of 164 degrees. This next one here would be a bearing of 229 degrees. Notice again that it's always from due north and opening clockwise. And then finally, 304 degrees, a bearing of 304 degrees. Now, I do want to emphasize that a correctly labeled sketch is crucial for these problems, for solving these applications. It is so crucial that you are able to get a picture or a sketch, even if it's a rough sketch, but your sketch must be accurate. It must be correct with respect to the application, okay? So make sure that you read carefully. All right, let's tackle our first problem. Radar stations A and B are on an east-west line, 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. Station B simultaneously detects the same plane on a bearing of 331 degrees. Find the distance from A to C. Now, ladies and gentlemen, these applications are applications of right triangles. So for each application, sketch a diagram. And when you sketch your diagram, if you do it correctly, you should have a right triangle. All right, so here is the beginning of my diagram. This is station A right here, and this is station B. We do know that they are 3.7 kilometers apart. Now, they tell us that station A detects a plane at point C, okay, at some location C, on a bearing of 61 degrees. Now, they just gave us one angle here. It's a bearing of 61 degrees, so we have to consider this or understand this to be due north. So let me show you a bearing of 61 degrees. So here we have due north here. I went 61 degrees, right? And of course, this is a sketch, right? So this is not completely accurate, but I went 61 degrees out here, and there is point C there. This is where they detect the plane on a bearing of 61 degrees. Now, I gave an approximate location of where C might be, okay? The important thing, though, here is not how far C away is right here. The important thing is that this is 61 degrees due north. This is a bearing of 61 degrees, okay? That's the important part. Okay, so here, this is where the plane is. Now, station B simultaneously detects the same plane on a bearing of 331 degrees. So let's show that now. So here it is, folks. Here's my due north for station B, all right? And then remember you have to open clockwise, right? Clockwise, 331 degrees. And there is the detection of the same plane at point C, all right? So this is our goal. Our goal is to find the distance from A to C, from here to there. Let's give that distance, I don't know, how about B? Let's call it lowercase b just because it's opposite angle B. So that's our goal, to find the distance of side B here, all right, from A to C. Keep in mind we have two significant digits. Look at all of the measurements that they've given us. The least number of significant digits is 2. So when we give our final answer for B here, for this chord A to C, the side length, remember 2 significant digits. And don't forget that we're talking about kilometers. All right. Now, this is the idea, folks. How can we take this given information, all of this is given information that we've drawn so far, and show that this triangle here is a right triangle? Well, the only way you can show that this is a right triangle is if you can show that one of these angles, of course, is 90 degrees. Now, I don't know about you, but it looks like this one has hope of being 90 degrees. I cannot assume that it's 90 degrees. I cannot assume this is a right angle. I have to prove that. So if this is going to be the 90-degree angle, because it looks like it could be, then I have to show that this angle and this angle here inside the triangle are complements of each other. So how can I show that? Well, let's get started. Let's find this angle measure inside the triangle here. The first thing I want to highlight is that a line drawn due north is going to be perpendicular to an east-west line. This is an east-west line. That's what they told us. And due north would be perpendicular to east-west, right? So that means because these two sides here are perpendicular, that means that this is a 90-degree angle, all of this. So that means this angle in here must be the complement of 61 degrees. So then we can figure that this angle in here, when I subtract 61 degrees from 90 degrees, I end up with 29 degrees. 29 degrees is the complement of 61. 61 plus 29 would be 90 degrees. So this angle inside the triangle must be 29 degrees. All right, so let's see if we can show this angle here, or find it. Keep in mind that they gave us a bearing of 331 degrees. Now I want you to watch this carefully. From due north here, all the way around, if I stop here, ladies and gentlemen, right here, that would be 270 degrees, 270. That must mean the angle that is inside this triangle right here must be 331 degrees minus 270. If you subtract this amount, if you subtract 270 degrees, you'll be left with just this angle here. So this angle must be 61 degrees. All right, now this is the point I want to make. If this angle is 29 degrees and this angle here is 61 degrees, notice that 29 degrees and 61 degrees are complements. If you add these two angles here, you get 90. That forces this angle to be 90 degrees because the three angles within any triangle must sum to 180 degrees. So this must be 90 degrees, therefore this triangle must be a right triangle. Now that we have a right triangle, I can use a trig function to find my unknown. So what I'm going to do is I am going to use this angle here. I could use this one here, 61 degrees, if I wanted to. So I'm just choosing this angle here. 29 degrees. Notice that this side length here is the hypotenuse of our right triangle. Notice that the unknown is the side that is adjacent to this angle 29 degrees. So I can say cosine of 29 degrees is adjacent over hypotenuse. Cosine of 29 degrees is adjacent over hypotenuse and solve for B. Or I could use this angle and say sine of 61 degrees would be opposite over hypotenuse. Sine of 61 degrees is opposite over hypotenuse. Either way will yield the correct answer. Let's go ahead and go with the first option, cosine of 29 degrees. So I set it up, folks. Cosine of 29 degrees is the side adjacent to the side that's called the hypotenuse. So this is adjacent over hypotenuse, B over 3.7 kilometers. I multiplied both sides by 3.7 to isolate b, and so I'm getting that b is equal to the product of cosine of 29 degrees and 3.7 kilometers. So b is approximately equal to 3.2 kilometers. Now remember to use two significant digits, and also do not forget to use your correct units, which in this case is kilometers. All right, the second way or method that we will use to express bearing will be to start with a north-south line and then use an acute angle to show the direction, which will either be east or west from this line. Let me show you some examples. Here are some examples. This one here, notice that how it's given to you. It's always north or south first, and then it's always followed by an acute angle, and then east or west last. Okay, it always starts with due north or due south, and then your acute angle, and then either east or west. So this one would have been 42 degrees due northeast, right? 42 degrees due northeast. This one said start with a due south. Start with a south line. So we started with our south line, right? That's what that says. Start with your south line and then go 31 degrees east from there. So this is an acute angle opening 31 degrees east. So the east or west is telling you the direction in which you are to open. Start with a due south line, so we did, and then it says 40 degrees west from that line. Okay, from that line. So this is the second method for expressing bearing. All right, here we go. A ship leaves port and sails on a bearing of north 47 degrees east for 3.5 hours. It then turns and sails on a bearing of south 43 degrees east for 4.0 hours. If the ship's rate is 22 knots, which means nautical miles per hour, find the distance that the ship is from port. I think it's so crucial here to do our best to get an accurate picture. So let's do that. Okay, I wanted to show you my sketch step by step. So first I drew a north-south line, okay everybody? A north-south line. I put the port right here, just, I don't know, anywhere on that line. I put it right here, all right? I'm calling the port point A. This is where the ship leaves port, okay? The ship is here, it's leaving port. And it's sailing on a bearing of 47 degrees due northeast. So what I'm going to do is open from due north, right? From this line, due north, from this line, 47 degrees east. So it's this way, 47 degrees. So let me show you that. Okay, so this is opening from this direction this way, right? I can actually show that here. I failed to show it. Let me just move this. Give me a second to move this just a little bit here. And then let me show you that my angle is opening that way. From this line, due north, opening 47 degrees east. Okay, and the ship is here. Now I'm saying it's at this point. Let's just call it C. Okay, just, I don't know, just because. So it's going from here, there. Now the ship is here. Now, when the ship reaches this point, it says it starts to turn on and sails on a bearing of due south 43 degrees east. So what I want to do at this point is draw a new north-south line here, a new north-south line through this point, okay? All right, here's my brand new north-south line, right? And from due south, that's what it says, from the south line, I need to open 43 degrees east. That means this way. So 43 degrees east here for 4 hours. Okay, everybody, so I opened from the line due south, right? Because that's what they asked me to do. And they also asked me to open 43 degrees. So there we have it, 43 degrees from due south, and now the ship is here. I just called it at point B. What I want to do is now connect A to B here, like so. All right, I'm trying to do this as neatly as possible. So I'm going to try to use the given information to show that this triangle that we formed here, actually, I'm going to outline the triangle now. This triangle here. Our goal is to try to make this or show that it is a right triangle. If I can show that it's a right triangle, then I can use one of my trig functions. Now, at the end of the day, they want us to find the distance that the ship is from port. This is where the ship is now. This is port. So this is the distance that they're asking us to find. Let's call this distance, well, let's just call it lowercase c because it's opposite angle c. All right. Let us notice that north-south lines, we have a pair of them, they are parallel, right? North-south lines are parallel, of course. So we have a pair of parallel lines, and watch this. This is a transversal, a line that is intersecting a pair of parallel lines. We discussed this in an earlier lesson. We also discovered, or were understanding the special relationships between angles whenever we have a pair of parallel lines and a transversal. We talked about how alternate interior angles are equal in measure. That means this angle here must be 47 degrees because this angle and this one are alternate interior angles. They're on opposite sides of the transversal and they are within the parallel lines. And now look what we have. 47 plus 43 is 90. 47 plus 43 is 90. That makes this angle right here, all this angle here, from one side of the triangle to this side of the triangle, 90 degrees. That's a right angle. We have a right triangle. Okay, there's my notation to denote that this is a right triangle because 47 plus 43 is 90 degrees. All right, we have a right triangle. Now, we recall this formula for motion. Distance is equal to rate times time, rate or speed times time. We can use this to find the distance from A to C and also the distance from C to B. I've labeled those sides B and sides A here. I labeled it side B just because it's opposite angle B and side A just because it's opposite angle A. So I'm about to use this formula, distance equals rate times time, to find this distance. Now, they told us the speed or the rate, 22 knots or nautical miles per hour, and they told us the time. So when the ship first left the port, it went for 3.5 hours. It traveled for 3.5 hours at 22 knots, nautical miles per hour. So I'm going to multiply this rate by this time to get the distance of this first leg. I'll do the same thing. I'll take the rate of 22 knots and multiply it by 4 hours, that's the time, to get the distance of the second leg of the trip. All right, these are my findings. When I take the rate and I multiply it by the time, I get 77 nautical miles. That's this distance here. And when I take the rate and multiply it by this time, I get 88 nautical miles. Now I can use a Pythagorean theorem here because this is a right triangle. We proved it. And we know side A now, we know side B, and I can use it to find side C, which is the unknown, the distance from the ship to the port. So what I can do is I can solve for C, right, by just taking the square root of both sides. So I did that, and I also plugged in 88 for A and 77 for B, right? That's what we found. And so I'm finding that C is equal to, now remember, we only have 2 significant digits, right? 2 significant digits. So you must only use 2 significant digits. So because of that, I must round this value to the nearest tenth, right? So 2 significant digits. So 0 here is not counted as a significant digit, all right? It is not. So there's only 2 significant digits here, all right? So there's our answer. This was a lot of fun. Check out this example. The subtense bar method is a method that surveyors use to determine a small distance d this is a lowercase d, between 2 points P and Q. The subtense bar with length B is centered at Q and situated perpendicular to the line of sight between P and Q. Angle theta is then measured, and then the distance D can be determined. Let's draw a picture for this for sure, right? A picture will help. All right, so here is the 2 points P and Q, okay? Now, the problem says that surveyors use this method to find the small distance D, which is the distance between these 2 points. So the distance here between these 2 points P and Q is what's called D. So let's label this D, okay? This is D. Now, this distance here is the distance between the 2 points P and Q, and they say that a subtense bar with length B is centered at Q. So that means this is the bar. This is the subtense bar, and it's centered right at Q, and it's perpendicular to this line of sight. So this subtense bar is perpendicular to this line of sight here. It's perpendicular to this line. Now, this bar is of length B, okay? Now, notice that what we have, or what we can form really, is a right triangle. You can draw that right triangle, or you can do this one here, right? Because they said that this bar is perpendicular to the line of sight. So this is definitely, indeed, a right triangle. Now, keep in mind that the subtense bar right here is, the whole thing is of length B. If the whole bar is B and it's centered at Q, then just this amount right here would be half of B. So let's go ahead and label that half of B. So this is half of the bar, and this is the other half of the bar of length B. Now they said that once the bar is here, located here, we can measure theta. So this is theta here, folks. Let me see if I can draw it. This is theta. All of this is theta. So let me see if I can draw it for you. So there's our angle theta right here. All right. So this is everything they gave us so far. So here comes the question. They want us to find D, this distance between these 2 points. Find this distance when theta is 1 degree, 23 minutes, and 12 seconds, and B, the bar, is 2 centimeters long. Notice how they gave you these measurements. Let's count significant digits. 1, 2, 3, 4, 5 significant digits here. And you have to count all these zeros. 1, 2, 3, 4, 5 significant digits. So remember that for our final answer. All right, so we definitely have a right triangle here, and we want to pull out one of our functions. Now, notice that the function is going to be of the function of theta over 2, half of theta. But because all of this is theta, we want this right triangle up here, or this right triangle down below. You want one of those right triangles. Let's just talk about this one up top. Here, let me highlight it in green for us. We want this right triangle there, okay? So we can't say theta because theta is from here all the way to there. We basically want to say half of theta. So I'm going to use a function of half of theta. And notice that we're talking about the side opposite theta over 2 and the side adjacent theta over 2. When I say half of theta, I mean theta over 2. This much is theta over 2. So opposite over adjacent, that sounds like tangent. So what I'm going to say is tangent of half of theta, right, must be opposite, which is b over 2, over adjacent, which is d. Did you guys catch that? Tangent of half of this angle, so theta over 2, must be opposite over adjacent, b over 2 over d. Now the question here is find D, find this distance. Now remember that theta is this angle here, right? So we're taking half of that angle, right? What you may want to do this when you start doing this calculation is change theta to decimal degrees. And if you do that, you'll find that theta is approximately equal to 1.386666667 degrees, right? And that's what theta is, 1 degree, 23 minutes, and 12 seconds in terms of decimal degrees, all right? So keep that handy. Now, what we want to do is work with this and isolate D. So can we do that together? So what I'm going to do to both sides first is multiply both sides by D, right? I'm going to multiply both sides by D. That'll eliminate D down here and put D right over here, okay? All right, and then what I want to do is divide both sides by tangent of theta over 2. All right, so that's what D will be equal to, exactly. Now it's time to start plugging in our information. Remember that B is 2 centimeters, so this is just 2 over 2, which is 1. So this whole numerator is just 1. And then theta we know is, do you remember we wrote it down, 1.386666667 degrees. So let's plug all this information in, shall we? So forgive my sloppiness, but it's 2 over 2 divided by tangent of 1.386666667 degrees divided by 2. Okay, now you want to be very careful when you punch all this into the calculator. Let me just keep on going here. So then D would be really equal to just 1 over tangent of. So what I did next here, guys, is I'm doing little by little, okay? I just punched in, let's see, I'm dividing this by 2. Okay, all I did was 1.386666667 degrees divided by 2. So this is 0.69333333, right? That's what I'm taking tangent of. So I actually punched all this into my calculator. I punch in 1 and then divided by tangent of this value, and I am getting that D is equal to, or approximately equal to, let's see, 82.63410,984. Now this is centimeters, but we want to use, what was it, 5 significant digits? So 1, 2, 3, 4, 5. That's where I'm going to stop right here, round to this 10th, 100th, 1000th place here. So my final answer will be that D is about 82.634 centimeters. Okay, everybody? So that was a really intense problem, but we got through it. And this is called the subtense bar method. Pretty cool. All right, here's the last example. It's pretty fun. John needs to know the height of a tree. From a given point on the ground, he finds that the angle of elevation, right, this is the given point on the ground, the angle of elevation to the top of the tree is 36.7 degrees. That's right here. He's some feet away from the tree. They don't tell us how far from the tree he is, from the base of the tree, but they do tell us that the angle of elevation to the top of the tree is 36.7 degrees. From this point, he moves back 50 feet. From the second point, the angle of elevation to the top of the tree is 22.2 degrees. Find the height of the tree to the nearest foot. Okay, so this is where John is standing initially. X feet away from the base of the tree. The angle of elevation is 36.7 degrees. From this point, he moves back 50 feet, and now the new angle of elevation is 22.2 degrees. All right, we're going to use the tangent function here to answer the question because tangent of 36.7 degrees involves opposite over adjacent. Those are the two sides that we're dealing with. and maybe I went ahead of myself here, I do want to say that we have a right triangle, right? And so please notice that the sides that are in this problem under consideration are opposite and adjacent. That's the reason why I'm using the tangent function. Okay. All right, here we go. So tangent of 36.7 degrees would be opposite over adjacent. So opposite over adjacent, h over x. What I would like for us to do here is to solve for h. Multiply both sides by x. So we get that the height of the tree is equal to the product of x and tangent of 36.7 degrees. Keep this handy, everybody. This is going to be really important. We'll come back to this. Now, let's do the same kind of thing, but with this angle. Notice that tangent of 22.2 degrees is opposite, now watch this, over adjacent. Remember, you don't want to just say that this is adjacent. We want a right triangle. So now you're looking at this larger right triangle here, okay? So the side opposite the angle 22.2 degrees is h, and the side adjacent is x plus 50, both of these, right? So I have tangent of 22.2 degrees is h divided by, or h over, x plus 50. Now please solve this for h. Multiply both sides by x plus 50. So now we're saying that the height of the tree is equal to the product of x plus 50 and tangent of 22.2 degrees. Now here's our logic. If the height of the tree is equal to this expression, and over here the height of the tree is equal to this expression, that must mean that this expression is equivalent to this expression. So now we will set each of these expressions equal to each other. So what we're going to do here is solve for x. Now this becomes a lot of algebra at this point. Now listen, this is the idea. Let me give you the overall kind of idea of where we're headed, okay? What we're going to do right now is try our best to solve for x. Once we have found x, we will plug x in to this expression here to find the height of the tree. If we can find x, then we can find the height of the tree. So we're going to come back to this. You may want to highlight this. We're going to come back to this expression when we're all done solving for x. So now let's use algebra to isolate x. The first thing I'm going to have you do is distribute tangent of 22.2 degrees. Now that we have distributed tangent of 22.2 degrees, I'll collect my variable terms on the same side. In other words, I'll subtract this term from both sides. So now we have x times tangent of 36.7 degrees minus x times tangent of 22.2 degrees is equal to 50 times tangent of 22.2 degrees. And we're on our way. Now, let me see if I can move the screen up for you here. What I would like us to do is to factor out the common factor of x here. Now that we have x factored out, we can divide both sides by this expression in order to isolate x. So there we have it, everybody. X is equal to 50 times tangent of 22.2 degrees, and all of that divided by tangent of 36.7 degrees minus tangent of 22.2 degrees. All right. Now, I'm not going to plug that into my calculator yet because that's going to give me some long decimal, all right? What I want to do is go back to, can I scroll back up here? Do you remember me saying that, hey, keep this handy, everybody, this expression, because once we find x, we're going to plug it in right here to find the height of the tree? Well, now we're ready to do it. So I'm going to replace x here with what we just found. So here we have it. Remember that h is equal to this product, and I just replaced x with this long expression, okay? So I just plugged it in there, substituted. Now be careful how you read this. This is 50 times tangent of 22.2 degrees divided by tangent of 36.7 degrees minus tangent of 22.2 degrees. And all of that, all of this times tangent of 36.7 degrees. So maybe if I write this out, it might look a little sloppy, but it may make a little more sense to you if I write it like this. Tangent, 50 times tangent of 22.2 degrees, right? That divided by tangent of 36.7 degrees. I don't know if this is helpful here. If it is, awesome, right? All of this times tangent of 36.7 degrees. All right, this is going to be the height of the tree. Now be very careful to plug all this into your calculator correctly using grouping symbols. And remember to never round your work. Don't round anything until the very, very, very end. Okay, I'm trying to make this, trying to do this step by step here. I punched in tangent of 22.2 degrees and I got this number here. I punched in tangent of 36.7 degrees minus tangent of 22.2 degrees and I got this number here, okay? I punched in tangent of 36.7 degrees, got this number here. All right, so it's probably helpful to just make sure that you are getting what I'm getting each step of the way. When I punch all of this in, remember they asked for the nearest foot. So I want to say approximately equal to 45 feet. Don't forget the unit, all right? So the height of the tree is about 45 feet. They told me to round to the nearest foot. All right, this problem had a lot of algebra, but it was a lot of fun. So this was really great. This is the end of this lesson and the end of this chapter. Chapter 2. All right, so I hope you had fun and I'll catch you later.